Hi, welcome back everybody to the Refinitiv developer community. This is going to be part 4 of our tutorial, looking into the article estimating monthly USA GDP figures via an expenditure approach and the Holt-Winters model. This far, we've had a look at the theory underlining our article and the estimators we're going to be constructing, as well as how one may use CodeBook and some Python fundamentals, as well as how one may use Datastream to collect the data we've used this far. In this part, I'd like to create some functions with you to graph our data and collect some insights behind that data we've been collecting. All right, this was a short introduction, so without further ado, let's get to it. All right, I'd like to start by showing you how we may go about increasing the font in CodeBook and Jupyter Notebook. All you have to do is click on View at the top left and then Presentation Mode. All right, it's a bit bigger like that. Let's go all the way back down to our code and use some Markdown to eliminate our space in our code. Okay, here now what we're going to do is add the components of our GDP that we've collected this far all together. To do so, I'd like to show you how we may go about adding columns to an existing data frame. To do so, I'm going to create this Python object called tests. It's going to be a pandas data frame for an empty list, so it's an empty data set. Let's have a look at it. You see this rectangle underneath which you should have your index if it was full, but it's empty, and to the right of which you'd have your column names. Before going on much further, I'd like to show you how we may use the native Python function range with letters as opposed to numbers. Usually what we do with this function is we'd go, for example, from 1 to, let's say, 10, and it would give you a range going from 1 to 10. But here instead, what we're doing is the same with letters. We're using the odd and character Python functions. And if I was to run this, you can see that it returns the letters in alphabetical order from A to F. It does not return G because, as always, the range function is exclusive with respect to its upper limit. Okay, let's say we were to try then and add this to our data frame test. All we'd have to do is use the test square bracket technique. Here we're using a square bracket next to our data frame. We're calling the column in question. This is a test column, for example, using the other technique that we used before with a square bracket to create a list with the for loop within the square brackets. So let's have a look at this. You see that it added the letters in question in alphabetical order, and this also added an index to our data frame if one did not exist, and that it is zero index. It starts at 0. Okay, let's have a quick look at our data frame this far then. You can see that we've got our consumption data on a monthly basis, our investment data on a quarterly basis, and our investment data on a monthly basis. We've got the same as well for government investment and net exports. But let's say that I wanted to add the quarterly data together for all of my components, my consumption, my investment, government investment, and net exports. Well, to do so, we can use the same technique we used before with the square bracket next to our data frame. Here, our data frame question is df, and I'm going to create this column called GDP component sum quarterly data by adding the summands, which is to say our consumption data, which is only in monthly basis right here, as well as our investment data, government investment, and net exports. All we have to do is add them together like this, and it's going to create this column at the end. Let's have a look. All right, here it is. We've got our consumption data all the way to what we had before, which is to say our net exports, and it added this GDP component sum exactly like we expected it to. The only thing though is that you can see that it's all NaN because as soon as there is a not a number within the summands, it's going to return a not a number, quite like we expect really. So let's have a look at our data frame without all of this. Here you can see that we have our component sum in a quarterly basis, but only where there is quarterly data available. We can indeed do the exact same thing, but with monthly data with our monthly step data that we've got. Okay, here we're going to add this column to our data frame. Next, I'd like to go through our plotting technique. It's going to be interesting to look at how we may graph all the data that we've got this far to try and gather some insight behind all that we've got. Okay, to go through what we could possibly graph, let's create some data, some random data. Here I'm just making it a line that uses pi, the mathematical function pi 3.14, as well as the sine mathematical function, the sinus one, and we're going to have a look at how we may plot this. Okay, First of all, what I'm going to do is use the Python function we've imported called Matplotlib, and I'm going to use its sub-library called pyplot, which I've shortened as PLT. The reason is I don't want to use the entire thing every time. For example, here I'm using the plt.subplot function, and if I was to not use this shortcut that I've created, I'd have to write all of that every time. Instead, I'm doing this to make it a bit shorter. This function of that sub-library returns two Python objects, and that's why there is two arguments right here. If you remember, it's something very similar to what we did above, where we created two lists, data proper and data full index above, and we delimitated them with a comma just like this right here. Now what I'm going to do is use the dot plot function for the axis for the AX object that was created with our data X and Y that we've created right there. This is going to create a subplot, and I can create a title for my plots that I'm just going to create simple plots. And I'm going to finally just use this fig.show to show you the graph that we've created this far. Let's run this. You can see that it's quite simple. It returns this sinusoidal wave, which is where we had our sine. Oh, there it is, our sine. And it's all white with black writing and our title here called simple plot. Let's go about making this a bit more exciting though. First of all, let's use the ax.setFaceColor to change the color of our face of our graph. Let's have a look at what this returns. You see that it changed the background color for the face of our plots, but it did not change the color of the background. So let's try and have a look at how we may go about doing that. All right, to change the surrounding color, we're going to have to specify the face color within the plt.subplot function that we've created above. Here I've also added this figure size just to change the size of our plot altogether. Let's run this. And you can see that it didn't only change the face color, but also the surrounding color with this mnemonic 0.25, which is basically just dark gray. But it makes it a bit difficult to read all of this. This is all in black. So let's have a look at how we may change that here. Okay, what I'm doing is using the ax.tickparams function for both of my axes x and y, and I'm going to change the color to white. Here it is. Now we can actually see our axes properly, but still not the title. So let's go about changing that title and a few other things. First of all, let's change the title so that it has a color white. And I'm also going to use this /n, which is code for return to a new line. So that simple and plot is going to be on two different lines. And let's create a Y and X label. Let's make it dollars and year, and I want them to be white as well. Let's run this. And you can see that I've got my simple plot in two different lines and my axis names US dollars and year. Note also that I did not put a space between simple and /n as well as /n and plot, because if I was to do this, you'll see that it's not quite in line. I'd like everything to be in line because it's actually printed the space here after simple and before plot. So if I was to remove that, you can see that it's a bit more centered. Okay, last but not least, let's have a look at how we may add a grid so that we can figure out the specific values for our blue function here. By the way, the blue color of a line is set by default by Matplotlib as the first color that it uses. Okay, what if I wanted to have a legend? What if I had multiple lines and I want to know which one is blue, which one is red? Well, then I can use the plt.legend function to do that. If I was to run this, however, you see that it does not have a legend. I did not specify the name of that function for that blue line. But thankfully, this is not something that needs to be specified when using real life data with pandas data frames, because we can use the column names as the function names. You can see here that I'm creating my data set that I'm going to plot. Let's use a pandas data frame function for our column GDP component sum, our quarterly data. Let's remove the NANs for now. And also let's specify the start date and end date. If you're a bit confused by how this is specified right there, you may try and have a look at how we may go about finding the specific timestamp object for any component. So here the component in question is that data frame, which is the one we've called dataset underneath, and we're using this iloc function we've seen before, the .index function we've seen before, and the 0th here, just noting that we are looking for the first timestamp. This returns an object that is recognized quite easily by pandas. This is why I'm using this here and there. Lastly, we can also use the technique we've used before to create our plot just like we did above. Okay, let's run this and have a look at what comes out. And you can see that this time we can have our legend returned properly as GDP component sum quarterly data like we expected it to. But we've gone through quite a lot in there just to plot a graph. So what we can do is create our own function to return this. You see here what I've done is I've created a function going through everything we've gone through before with quite a few arguments right here. But don't worry too much because most of these arguments I have predefined, which is to say you don't have to say what the Y label is, what the line color is. All of this is already defined right there for you. There is also a bit of logic going about the data subsets depending on the start and end date that was chosen. But all in all, we're using the technique we've seen above with some further logic, again, just for the start date and end date of our data frame. We're also in this function allowing the user to choose whether or not they want a grid within their graph. If we were to run this, we'll then have our function in memory and we can use it for any of our data sets. Let's have a look, for example, if we wanted to do it for our GDP components of our monthly step data as opposed to our quarterly data. And let's specify a longer title so that we know exactly what we're talking about. Note that we've named our function plots 1ax. 1ax because as you see here, there's only one y-axis and we could have, for example, two axes showing two different currencies, for example. Next, let's collect our published USA GDP data. Remember that it's only published on a quarterly basis. Let's use some markdown to delimitate where we're at and collect our data with our trusted function we've created before, add to df with our Datastream getData function and the correct multiplier. Remember, it's GDP, so it's quite high. Okay, if we do this, it's added it to our data frame, and let's create a monthly step data column for what we've done above with our function quarterly to monthly. Okay, let's have a look at that column and we can see that it seems to have worked just like we wanted to. Now let's plot everything we've got this far so that we can have a look at whether or not we've done things correctly. We're using our plot1x function with a specific title that we've delimited and a data set that we've chosen, which is to say our data frame, and we're going to remove all of the not a number row. We're also delimiting our y-axis and we're specifying which data sets within our data frame we're going to be using. This is quite a good graph in that it shows us all of our data this far, but it also shows us our GDP that is published by the official figure and also the GDP component sum, the sum of everything we've got this far. And you can see that they are purple and blue. And the purple and blue line are so close to each other that you can hardly see the difference between one and another, which means that our technique adding these components may be very accurate in assessing GDP. Okay. So next, what we're going to do is that we're going to start applying our hot winters model to estimate monthly GDP figures instead of just doing this step function that we did up to now. All right, so I'll see you in the next one.